Okay, so we've been talking, well, previously we talked about finding the area of parallelograms, and then Monday we talked about looking at triangles and trying to reason through parallelograms, the way we've been finding area there to find the area of triangles. Well, today we're going to talk about a nice, easy formula that we can use to find the area of a triangle instead of having to do all that extra work. So let's look at this first slide here. All right, Caleb's coming in. Good morning, Caleb. Morning, Caleb. We're talking about the area of triangles again today. We're going to go through a really easy, quick formula we can use instead of having to do all that extra work. So this is just our first slide pretty much on the subject. So all right, we're going to look at some examples of bases and heights in a triangle, and then we'll look at a couple of examples, or non-examples, excuse me, that don't represent heights in a triangle. So just like with a parallelogram, we can choose any side of a triangle to be our base. Also, like with parallelograms, I recommend finding one that, if we can, finding one that's completely horizontal or side to side, or completely vertical, which is up and down. It just makes it simpler. So let's look at these top three right here. So in this first example, they chose the base as the bottom segment of the triangle. Okay. So from there, just like in parallelograms, once we decide which side we want to be the base, we draw a perpendicular line to the opposite side. Now on triangles, sometimes we won't run into an opposite side. So we have to find the opposite vertex. So does anybody know what a vertex is? If not, it's okay. So a vertex is basically, it's a corner of a triangle. So a triangle always has three vertexes. So we've got one there, one here, and then one there. So when I say we need to draw a perpendicular line from the base to the opposite side, we're drawing, in a triangle, we're drawing a perpendicular line from the base to the opposite vertex. So in this first example, again, they chose the base as this line, and then they drew a perpendicular line to this opposite vertex here. So you may be wondering, well, what are these lines here? Because they're not drawn to any opposite vertex. They're just kind of random to this line up here. Well, just like in our parallelograms, the examples that we saw previously, where sometimes when you have to draw the line outside of the parallelogram to find the height. Well, that's true sometimes in a triangle also, but just remember that regardless of the line we draw, we always want to focus on this vertex, the opposite vertex. So if we have to draw the line outside of the triangle, we want to imagine another perpendicular line going across the vertex. That way we can draw the line segment from the base anywhere in the triangle that we want. So let's look at this other example. That may be a little confusing. So whenever possible, I always recommend drawing a line directly to this vertex. That just makes it easier. So in this example, in the middle, they chose the base as this line segment. So no matter which line we choose, we have to draw a perpendicular line to the opposite vertex. So where is the vertex? Where are the vertices, which is plural for vertex, in this triangle? Can you tell me what is the vertex again, anybody? Essentially?
I don't know, I remember.
It is the corners of the triangle. So always look for the corner opposite of the base. All right, so again, they chose this line segment as the base, and then they drew a perpendicular line to the opposite vertex or the opposite corner. Now, in this last example on the right here, you'll see what we were talking about, drawing a line outside of the triangle. So they chose this line as the base. And then as we know, we have to draw a perpendicular line from the base to the opposite vertex, but they drew it this time outside of the triangle that you see here. So they're not drawing it directly to the vertex or the corner being right here. But it can only be drawn, let's choose another color here. It can only be drawn as high as the opposite corner. So if we wanted to draw it to the corner, we would draw it from right here. Does that make sense? The line, just like in parallelograms, the line is always going to be perpendicular to the opposite side. If we're drawing it to the opposite corner, we just draw a line directly underneath the corner. But if we're drawing it outside the triangle, then it can only go as high as that corner. I hope that makes sense. But again, I encourage you, whenever possible, always try to draw it inside the triangle like you see here. So down here at the bottom, these are non-examples of line segments that represent heights. So again, you can choose any side you want to be the base. So in this bottom example on the left, they chose the base as the bottom line, but they drew the height from one corner to the other. So it's basically another line segment of the triangle. So does that line look perpendicular from the base to you all? No, it doesn't. So that can't be our height, can it? And what about this line here? Does that look perpendicular to the base? It doesn't. It's a little closer, but it's not exactly perpendicular. This one here may be a little tricky because it is a perpendicular line to the base, but what doesn't it do? Does it come all the way out to the corner? See, that line would need to stretch all the way out here. So that's not an accurate representation of the height. So again, when you find your base, you draw a perpendicular line to the opposite corner or the opposite vertex, and I always encourage you to draw it right underneath that opposite corner there, like you see in this middle triangle at the top. So let's go a little further. We'll answer these questions, just true or false. I'll go through them and answer them for you. So number one, any side of a triangle can be a base. Well, we know that that's true because we just discussed that. There is only one possible height. Well, no, that's not the case, so that's false. How do we know that? Well, you can draw any perpendicular line, so as many lines as you can fit in there, really, from the base to the opposite vertex to get the height. And again, I always encourage you to draw it to the opposite corner instead of drawing it outside of the triangle, if at all possible, because that just makes it simpler for us. So number three, a height is always one of the sides of a triangle. And we know that that's false because we saw in the previous example that a lot of times the sides of the triangle are not perpendicular lines from the base. Sometimes they are, but in most cases they are not. So number 4 here, a height that corresponds to a base must be drawn at an acute angle to the base. So what is an acute angle? Does anybody know what that is? If not, it's okay. We haven't talked about that. So an acute angle is any angle that's less than 90 degrees. So is that the line segment that we draw to the opposite vertex, what kind of angle is that? If it's perpendicular to the base, do we know what kind of angle that makes?
Right.
A right angle, that's exactly right. So number 5 here says, a height that corresponds to a base must be drawn at a right angle to the base. So is that true?
Yes.
Yes, that is true. Correct. All right, number 6, once we choose a base, there is only one segment that represents the corresponding height. Now, we talked about that previously in number 2, so we know that that is false as well. Number 7, a segment representing a height must go through the vertex. Well, we know that's false too, but as I said, I always encourage you to draw that line through the vertex or the corner whenever possible at all. It just makes it so much simpler. All right, so on the next slide, how long should a segment that shows a height be? Well, it has to stop where?
The line.
All right, if we're using this line here as the base, and then we draw the height, where does it have to stop?
I tell him. The top.
The top. It has to stop at the opposite corner, or the opposite vertex, as they say. I like to call it the corner. So how long should it be? Well, it should be however long it is from the base to the opposite corner. So that kind of leads us directly into the second one there. If we draw a perpendicular line from the base, where do we stop? Well, we stop at the opposite corner. All right, so let's do some examples here. We're going to find the formula for the area of a triangle. Now, you'll probably wonder, once we write this formula down, why didn't we do it this way from the beginning? Because it's so much easier. Well, that's just what we do. So let's identify a base and a corresponding height, and then we'll put their links in the table over here. And then we're going to find the area of each triangle and record it in this last column. And then we'll write that nice, simple formula that we can use from now on to find the area instead of having to do all the extra work like we talked about. Oh, excuse me. So in triangle A here, can everybody see that okay? It's a little smaller than I thought it was going to be. So let's pick a base here. We'll use this bottom line that we see. So how big or how long is that line segment that we picked for the base? Can we see that?
Ten.
10, that's right. So over here in our little table, we'll write 10 for the base. So now what do we do? If we've picked this bottom line as the base, what do we do next?
Height.
We find the height. And how do we do that? We draw a line, perpendicular line. Where do we draw it to?
Top part.
Top point, that's right. So let's count these. So how long is our height here?
7.
7. So do you remember how we find the area of a parallelogram? Remember that nice and
base times height.
right, that's exactly right, Linus. Thank you. So let's work this out, how we found the area of a triangle yesterday. I'm going to make an exact copy of this triangle and then rotate it to make a parallelogram. So if our formula to find the area of a parallelogram is base times height, we know our base is 10 and our height is 7, what is the area of this parallelogram that we just made? Whoop.
70.
70, that's right. So what do you think the area of the triangle is going to be? Remember what we said on Monday? Half, that's right. So let's take this triangle away. So what is half? I'll try to write this in here as neat as possible. So we've got 70 divided by 2. So what does that come out to be?
35.
35. Perfect. That's exactly right. So let's do one more. I'm going to do B. So which side do you want to choose as the base, Linus? You want this one or this one? Top or left?
Top.
Top. Okay, so how long is our base there? 11. All right, I'm going to write it down here and see. All right, so how big would our height be? So if we're picking this line as our base, what do? We draw a perpendicular line from the base to the opposite corner. They've already done that for us, haven't they? Is this line perpendicular to the base that we chose?
Yes.
Yeah. Did they draw it to the opposite corner? They did. So how big is our base there?
1, 2, 3, 4, 5,
1, 2,
6.
6. That's right. So what we've been doing, we've made a copy of the triangle. And then we rotate it to get the area of a parallelogram. So if our base is 11 and our height is 6, what is the area of that parallelogram?
66.
66. And what do we know about the area of a triangle once we find the area of the parallelogram that we made?
Half.
It's half, that's right. So what is half of 66?
33.
33. That is perfect. Excellent job. So let me ask you, if we know that the area of a parallelogram is base times height, and we know that the area of a triangle that we've used to make that parallelogram, is half of that, what do you think our formula should be for the area of any triangle that we're working with?
Try this.
So if we've got base times height for our parallelogram and then we take half of it, what should our formula be, do you think? How about this? Base times height Sorry, my drawing skills aren't great again. Base times height divided by 2. Or another way to write that is 1/2 times base times height. Okay? So when we're using a calculator, this first one, base times height divided by 2, will probably be a little easier for you to use on a calculator. Okay. So we'll do a couple of these and then we'll get you out of here. So let's look at A here. What is our base? Can you pick out the base for me?
Top. 5.
5, that's right. Let me write this on here. Okay, so I'll circle our base in red. You said it's 5. So what is our height?
6.
6. So we know our base and our height. Can you tell me what the area would be using our formula?
15.
15, correct. Nice job.
Yes.
All right, let's do one more. We'll do B. So what is our base? Remember, you can choose any side for our base in the triangle. Which one would you choose? 4, that's right. So what does that make our height?
4.
4. So what's our area?
8.
8, correct.
Yeah.
Perfect, nice job. All right, we'll do C. I think I said one more, but let's do C. In this one, it's a little trickier because remember what I said, sometimes you can draw the line outside of the triangle. And I encouraged you to draw the line inside the triangle whenever possible. Well, this is one of those times where you can't draw a perpendicular line to the opposite angle, or excuse me, the opposite corner or vertex. So if we pick, let's say we'll pick 7 as our base here. We draw a perpendicular line inside the triangle. That doesn't reach all the way to the corner, does it? We've got this extra space here. So what they've done is they've drawn it outside of the triangle. You see that here. So what they had to do was draw these imaginary lines out further just to kind of represent where we would draw that perpendicular line. Does that make sense? So like I said, this one may be a little tricky, but we still answer it the same. We just have to figure out the base and the height, or the height, a little differently. So I'll work this one for you. So our base here is going to be 7. And in this one, like I said, they drew the imaginary line out here so they could draw the perpendicular line segment to the opposite corner, or the opposite side. They drew it outside of the triangle. So our height would be 3. So using our formula, base times height divided by 2, we know that, well, I'm going to have to use my calculator there. We know that the area is 10.5. So instead of drawing it like that, like they have it shown here, you could also do it this way. You can draw that imaginary line this way, and then draw the perpendicular line from here to the corner. And it would also be 3. So does that make sense? Do you have any questions about that one? I know it's a little trickier. Just remember, once you figure out what your base is, always draw it to the opposite corner or opposite vertex, and keep that inside the triangle if at all possible, like in A here. But if you have to draw it outside, draw that little imaginary line so you have a nice perpendicular right angle to draw to the corner. So let's look at this last slide just to kind of rehash what we've done. So previously we looked at the area of a parallelogram and found out that it can be determined by using the base and the height. So we multiplied base times height when we were doing this. So today we use that same formula to figure out how we could find the area of the triangle. So we located the base. We know that we can choose any base we want, or any line that we want in the triangle to use as the base. So how many possible bases does that give us? Well, there are 3 possible bases because there are 3 sides of a triangle. Now, how do we locate the height once we know the base? We do that by drawing a perpendicular line from the base to the opposite corner, or the opposite vertex. And then we know that we can use those measurements to find the area. And what is our formula to find the area? Can anybody tell me again?
Divided by 2. You're starting with base times height divided by 2.
Base times height divided by 2. That's exactly right. Now, how do we know that this formula works? Well, we know that once we find the area of a parallelogram using base times height, that the area of the triangle is exactly half of that. So the last thing here, you learned that any side of the triangle can be the base, but not all sides can be the height. Are there cases in which both the base and the height are sides of the triangle? When does that happen? Well, the answer to that is yes. And that happens when you see a situation like in B or in D. And what you're looking at there, they've already given us what's called a right triangle. Now, a right triangle means that 2 of the sides of the triangle, like this side here and this side here, when they come together, they form a right angle here where they meet. So a right triangle means that 2 sides of the triangle, when they come together, they form a right angle. And a right angle is a 90-degree angle. So that's what we've got for today. I hope that I wasn't too confusing there. But do you have any questions or anything for me, or any concerns about our lesson today? No? All right, good deal. Well, I will post an exit slip here shortly, as soon as our video finishes uploading. And we will see you all next week on Monday.